Howdy humans and other entities. I'm Bill Rayford and I'm here to talk about logic. And logic is a word, and the name of this logic is a funny word. It's a neologism and it's called ibgib or ibgib. It's pronounced G like in gauge or garage or gigawatt. Now, right now, the logic that you may be thinking of is like the sock drawer problem, right? So when I was young, I loved puzzles, and there was one that was called the sock drawer. And you have a sock drawer. It has 2 black socks, 2 white socks, and it's in a dark room. How many socks do you need to pull out to guarantee you have a matching pair? I loved these kind of puzzles. I ate them up. And of course, you think about it, you go, oh gosh, well, if I grab just 2, it could be a white and a black. You don't really know. If you grab 4, that's overkill. You know, what's the answer here? And, you know, you come up with the answer. Oh, it's 3. It's 3. That's our logical answer. Because, and here's how the logic goes. If you grab 3, you're guaranteed to have at least one of each different color plus 1. So that plus 1 is always going to be the matching one. So if it's 3 different colors, then you grab 4, right? If it's 5 colors, then you grab plus 1, you grab 6. And this is the kind of logic that the entire world is based upon. Or at least it seems that way right now with architecture, with computer architecture. This is the kind of logic. But really, are any of those socks ever black and white? You know, in my sock drawer, you know, I use bleach. You know, at what point, how many times do you bleach it to where that black sock's not really black anymore? Or how many holes do you get before it's not really a sock anymore? It's just this thing that you need to throw away, but you don't because you're lazy and cheap. And you want to keep that sock until you can get the absolute most out of it. And this can even be applied to bits. So right now, people think of discrete bits in terms of Shannon information. And they're never actually ones and zeros. Those are the boxes we have given ourselves. And when you go to execute code and you go to read a piece of data, you know, maybe that data is corrupt, right? Is that a 1 or a 0? Well, I don't know, it's corrupt, right? It's some other thing that we're just sort of shoving under we're sweeping it under the rug. So ibgib is a logic to handle that. This is a prototype that helps to marry the conventional, you know, abstract logic that we know and love with a living logic, a more biological approach to understanding distributed computation. So, all that in play, let's look at the prototype. So first, it's a big screen. You know, what's going on here? Let's zoom in just a little bit here. Okay, when you first come here, you come to the home tag. You'll see this. We're inside of this thing. Here's our sort of details look. So if we go here to the home, I've added a few comments by typing in here, just like we're looking at it as a chat, right? So pretend this is a chat view or a chat app, and I've added these to help us dog food describing this this app. Now, first, caveats. We don't really care about caveats. I'm going to look at them. You can pause it after it loads, but the first one obviously is that it's an MVP and it's slow. This is not slow because, well, it's similar to why Bitcoin is slow, because you have monotonically increasing database. But this is slow because of, well, his design decisions that I've had to make, being the only programmer on the entire stack, including the protocol and everything. So it's slow. It's got some other problems here. You can pause it and look at it. We're going to go back. So that caveat is throughout the entire thing. So we're just going to go ahead and we'll delete that. Okay, you can swipe right for delete, swipe left for archive. Really, there's no difference right now in the prototype, except for the names of the relations that it does. So how I use this MVP right now, right? So I just click that, and single clicking navigated to that as our context. So it's kind of like going inside of a folder. You can think of this as being a folder, but the thing is, anything can be a folder. Any datum, right? Any datum, anything, any entity, anything that we're talking about. So I just added a picture, right? We can go inside of that picture just like it was a folder. We, just like the data of discretely, assigning 1 or 0, which was very, very useful, we came up with the paradigm of files and folders. We're starting from nothing. The smartest people on the planet had to find a way of organizing that nothing into something that people could understand. And we came up with files and folders. So much so that even the bleeding edge right now, in my opinion, the best technology out there is IPFS. They still think of it as a file system. And or even if they don't necessarily think of it that way, they still conceived it as a file system. But that's going to have technical debt. So anyway, we've gone inside of a picture. Inside this picture, we can say, we can add data inside the picture. Really, we're building out a DAG. It's a Merkle DAG. It's a cryptographically, with cryptographic links. And we've just added text inside of that picture. We can also add a picture inside the picture. And this is how I use it when I'm doing gardening. I'll take a picture of an entire picture of one of my garden beds. And then I'll go inside that garden bed and take a picture of one of the plants inside of that garden bed. In this case, the example is here, we've just taken a picture, taken a screenshot of just the home button here. So inside of this, we're adding another picture. Okay, and so this is how I use this. This is one way that I use this, sort of like a mind map, but with the ability to add infinitely recursively pictures inside of pictures, notes inside of notes. So I actually have a picture of my backyard with a picture of inside of that, the picture of a section of my garden. Inside of that, I have pictures of individual garden beds. Inside that, I have pictures of individual plants. Okay, inside a plant, you can take a picture of an individual leaf, right? And you can track these things over time because each one of these things is deeply linked. So if you look at the top here, this is the link, although this to the right is metadata or just the app. But here is the address for this ibgib, okay? So all data is content addressed, which is nothing new in the Web3 world. But it is content addressed in a very special way that no one else has. And we'll talk about that in just a second, but I'm showing you how I use this. Okay, so going back.
Yes, very slow.
So pictures in pictures, notes, like a mind map, also do a to-do list. Okay, so we can go in here and we can say, you know, all right. So one of the things we are just learning as a civilization is the idea of decentralized apps. Okay, but we're still thinking of centralized silos of data. And this, one of the things that this is meant to show is what a more decentralized view into shared data looks like. So the only thing out there right now that this is like is how Git is used. Git is like a version control for text. They do blobs and stuff now, but it's ad hoc. It's highly optimized for text. But people have their different branches. They have their different nodes. You have remotes. You can push between the nodes. Some companies have tried to utilize that and turn it into like cryptocurrency type things. But really, again, that's it's sort of a shoehorn process. It's an ad hoc process, is what I mean. So to use this as a to-do, we go here to the program bar, and these are not just programs to select from. These are ibgib. They have their data as ibgib. And now we're viewing the same context as a to-do. Okay, so before we were looking at it like it was a chat. And now we're looking at it like it's a to-do. And so now we can, even a picture, we can say a picture is done. So if you want to have a visual to-do lists, I've done that before, where you just take pictures instead of writing down what you need to do. You take pictures of the stuff and then you check them off when you're done. So here, I can check off this, and that sort of thing. But the most important thing to take away here is that this to-do app, A, is looking at the same data, and B, itself is memoized, or like its state is also an ibgib. We can go to the app's state. We can look at it through one of the other, I only have 3 default dApps. So we can look at it through the raw view. And here is that to-do app, right? So here are the settings that it has. You can imagine you have different apps and you can send them to different places using the same mechanism that you would use for any other transferring of data between spaces. So what I mean by this is that when you go to git push from one node to another node, that same mechanism that's sharing your repository, right? So behind the scenes, Git has an object, a content addressed object database. When you go to send that graph, you can also send the actual app that you're using. In the future, you can have this entire thing is more of like a superset of how version control works. Again, we'll get to that. But you can send data along with the thing that views the data using the same cryptographic scheme that however you want to use it. So yeah, so you're not just git pushing data, you're git pushing metadata, including the git's protocol and git's setup itself. But so anyway, how I use this right now is a to-do, or one of the ways I'm using it is as a to-do. And the to-do app, the app is a view into the data, and the data can be moved around and can live similarly to how you think of source control living. But right now, we're thinking of semantic data. Now we've moved away from text, and we are talking about semantic data. And so when we do that, we can think of not only our data that is produced, but derivative data and metadata like the to-do list. So robots, this is one other thing. This should be very important to people nowadays, especially with, like, say, ChatGPT being so interesting to people. If we click this up here, this is our robot bar, robot with two B's, because this is more like Robbie the robot, the original robot story from Asimov. That's the two B's is in honor of Robbie, Mr. Roboto. So this is a random robot that I'm setting up. It has some default settings. And so Randie is thus named because you can show him things and then he'll spit them out at you just randomly. You know, it's like one of the most basic things that you can do for a robot. Now, it's slightly different than a chatbot, because a chatbot is only one type of what these robots can be. So you can think of Randie being like a chatbot. So first, I haven't used Randie in a while. I hope I haven't broken him working on the other ones yet. So I told him to say something with this little button here, but he hasn't seen anything yet. So he doesn't know, there's nothing for him to shoot out. So if I want to say, I go into this is our context. These are the buttons. These work on the context. These are our child items, child not being inside of them, but for right now, we'll just think of them as children. So anything I do up here works on the context. I can long click or long press, depending on if you're on your phone or not, any of the items, and that'll bring up a little overlay with some other, very similar style commands. That would work on just that child item. But for the robot, I give the little eyes. It says got it down here, way down here, because, that's made to be a web app. So now, wherever I am in whatever context that I'm in, say we're over here in favorite, duplicate. Back while that's going. So now I'm inside of favorites. I can add comments, or I can tell him to say something. And what he'll do is he will attach that ibgib that I showed him, and he'll put it inside of this context, because he's only seen one thing, and he's going to tell you, hey, here's the one thing. If we showed him multiple things, it's a very simple, even distribution. He picks one of them and shows them to you. But the interesting part here is, and the way I use it, is that he relates the actual deep linkable item. And so now when I can click on it and go directly to it. So it's like a link also. So he links that data to the context that you're in. Okay, so if we were in favorite, that's our context. That's the folder. It's like our folder that we're inside. And he added a link to some data. Okay. So that's how Randie works. I'm working on a wordy robot. We can go over here, create a wordy robot. Wordsworthers. You can name them whatever. It's got some default settings. Don't worry about that. So one of the things I do is we'll just add a tag. As soon as the slow prototype loads the GUI. I usually say languages and Spanish or something like that, but we'll just do a tag directly for Italian. Whatever. Pick something. Right. So one of the big use cases for me is learning foreign languages. Okay. So right now you have like the intro type of learning languages, foreign languages or whatever, learning information. But eventually you hit a spot where you need to be driven by your own stuff. And the idea is that similar to using spaced repetition and other things like in SuperMemo, but SuperMemo, for those of you that are aware of that existence, it has a way of sort of overflowing with data. You can't keep up and just try to do individual little flashcards. And so the wordy robots, did I copy that? I did. Now let's see if it'll be, there we go. It's a little bit better. Okay, so you paste in something here, and we're going to show Wordsworthers or wordy guy. Could have given him an Italian name. We're going to go inside that. Wordy guy is still selected. I'm going to tell him to look at it. He's got it. And then there's different strategies you can use for where to put it. We could actually put it even on Wordy's ibgib, because just like everything else, Wordy, guess what, is an ibgib. His data is all the same data, and you can send Wordy to various places using the same substrate that you can send any data, including a chat, which we're talking about is super awesome because it reduces attack surface area. It's dry. Okay, so we're wordy guy. Now for him, it's a little bit more of like a chatbot interface. He's awake. The question mark is like saying hi, is like a wake word. So we already showed him something. He'll say he doesn't see anything if he hasn't seen anything also, just like random guy, the random one did. So he does a couple different reinforcement strategies for learning volare, right? for learning your text. So you can go through, you can just do your first lines, okay. Penso che un sogno così non ritorni mai più. Okay, so Echo, type these back to me. Stelle, improvviso, sogno, coste. I don't have it where it does accented. That's filtered out right now from validation rules. So, improvviso, sogno, cose, te come tramonta. Okay. And so this is how I use it a little bit. It's still not quite good enough and not smart enough to really be as useful as I want it to be, but it's better than nothing right now. Soltanto degli svaniscono. Okay, so that's how I use the robots. Okay, but this is just this prototype. We're gonna go back to our tags, home. This is just our prototype. And that's not really the importance of this video. Where are we at time-wise? 28 minutes. So you've seen how I use a little bit of how I use the current prototype. We can also synchronize this with among devices. It's a terrible implementation. It's very slow, and it has a little issue right now with the to-do. That's simply because I don't have that nailed down for where to go. I don't have everything nailed down for transmitting graphs among spaces. So anyway, it's a prototype. It's just me working on it. Hey, we already talked about the caveats. So that's how I use it. So here, the next phase. We'll archive that one. Isn't that fun? Archived. So why should you care, right? What do you even, if you've gotten this far, geez, what are you doing here? And to just go into a little bit more of the technical side of it, of how this differentiates itself, it differentiates itself a lot. But the two things I'll look at are why the DID, the decentralized identifier, doesn't suck. And that's the standard that's coming out of the W3C standard for combining multiple blockchain or DLT technologies and having a decentralized identification system. And then we're going to talk about data mobility a little bit more in what I call living version control. Okay, so first we'll go inside there. Does Control T? No, it doesn't. Control T should stay in the container, but it don't. What? Okay. Oops. Oh, I don't have Vim installed on this. Oh, goodness. Anyway, it found it. Here's the DID spec. This is a spec living in Web 1 space, even though it's for the Web 3. Maybe they have another space, but so why the DID doesn't suck. And I'm going to talk about this in context with how ibgib's data architect is designed. So look, here's what they have. They have a scheme, they have a method, and then they have the hash, the identifier. So this is already a little bit more than it needs to be. Okay, and that's because, and here's the document. Once you load the document, that's you get a more full look into it. Now, it's decent, but let's look at, I'm going to duplicate this. Let's look at the raw data for, we'll hide those bars back up, or we need to look at this. Okay, so this is the raw data for this ibgib. Okay, this is our address. Here's the ib, here's the gib, here's the data, internal data, and here's relations. These are named links, named edges in a graph. This links to comment gib, which is a primitive. The gib can be implied. We'll get into pre-optimization, that sort of thing. But so DNA is a named edge. The name is DNA, and it links to other data. Here's fork, and then you see the caret, and then you have one hash. Okay. Past. This is like this is another named edge, and it's another special one. The DNA is a special one. Ancestor is also a special one. That's, of course, by convention in version 1 of the ibgib protocol. If you look at the 0 in the past, you notice there's only one hash. And then if you look at the first one, there's one hash, there's this, and there's one hash, and there's a little dot here, and then there's even more over here to the right, right? There's another hash over there. So, but my point is that instead of hard coding what the scheme is for any address, so most architectures have, like, say, Git, is just the hash, right? In this case, what I went with was this ib caret gib. Okay, so the ib by convention is the metadata, and the gib is the hash. The ib is per use case, so this is fork. The use case is DNA version 1 fork. That's the metadata we want to carry with it. Mutate, and then there's another one, relate. Those are our 3 transforms. I'll get into DNA at some other video. But the point is that you have some metadata. The one that most people have is just the hash. But really, you can have any schema for any metadata that you want to have. So if we wanted to add, that'll be confusing, but if we added another, even though we're in the raw app, we can still add data to it. So now those of you who are smart may have noticed, the N has grown here. Our hash has changed up here. The TJP part, this is the same. If you go back in the video, you can look at it. And our past has increased by 1. That's because, unlike a blockchain, this is aggregating each datum holds the entire history. That's per use case. These are just dynamics for growing graphs, and really that's the future here, is dynamics of graphs. So one of the dynamics that I'm talking about is why the did doesn't suck. And so you have a per use case ib metadata. In this case, it's a comment space and then some text. So W2H, should you care, that's just some subset of a scrubbed text. What that does is that avoids collisions for just hashes, and also gives us useful metadata without loading the entire object, the entire record. So this whole record, ibgib, if we just close these and we look at just the raw all at once, right? That takes time to load this. It takes time to load if you were going to go traverse, the past or whatever other pieces. It takes time to load those. So there is a give and take, pluses and minuses of what trade-offs of what metadata you want to have, depending on whatever your use case is. So this is a huge differentiator between this W3 Web3 approach and everyone else, is that this is very, very flexible. In fact, by convention, you can think of just a hash as being one schema that doesn't have a delimiter, and that you're adding, multiple. You can add multiple metadata pieces onto it. So just the gib, and then you add the ib. But so from the very beginning, we're thinking of that. IPFS, the one that I said is, in my opinion, the best one out there right now, they were very smart in having their multi-hash very prescient there. The difference is that I believe is to be able to convert the same datum from one addressing scheme to another addressing scheme. Whereas the ib, this is all always a JSON record. Actually, it's not always a JSON record. The way the hashing is created is a hash of the ib, a hash of the data, which is a JSON string, and the JSON string of the relations, which are the named edges. So that's how the gib is created. But still, they are thinking of just the hash, or primarily the hash, because you think, oh, this is inefficient. But you have to think of efficiency as not just a naive thing of space efficiency. There are different dynamics per use case on what efficient means. And the use case that I personally have always chosen, or the dynamic I've always chosen, is simplicity. So we're trying to make this as simple as possible from the very bottom, but with a couple pieces that are necessary. So like the hashing part at all, that is. So I've always selected for simplicity, because simplicity enables flexibility. But we want a couple things that are really, really necessary, because we're thinking of time, and we'll get to that in just a second in our second part. But just finish up why the did doesn't suck. They have some metadata and a hash. That was good on their part. Now, if you just use that throughout your system, not just for the decentralized identifier, then you start to get some of the benefits of what the ibgib design has. So the second one, data mobility and living version control of robots, AI models, apps. So not just flexible, now we can think of, if we go back to thinking of our sock, conundrum, right? Our sock logic. You go, oh, this is, you grab 3 socks, when really the term sock is fuzzy. Your instantaneous decision on if it is a sock is fuzzy. It's always changing over time. That sock is degrading. If you think of an epoch or something, an eon, at one point to those molecules, where does that sock stop being a sock, right? So there's a huge gap between what we think of as the perfect algorithm for Web3 stuff. Like I have my cryptocurrencies, it has its proof of work or proof of stake, that sort of thing. We have our mathematical model for this, but when you go to apply a mathematical model, the applicability of that is always based on some constraints. And whether or not those constraints are still relevant is the beauty of life. Okay. If you think of, this is the thing for all time in all existence, right? This is our model of data. Then you are setting yourself up to die when the context, the environmental conditions, when they change. So from the very beginning, we're thinking about data dynamics and this idea of a living version control of anything evolving over time in some space. And this is actually the design of that has that at the very root of it. So it's like Git, where Git is thinking of version control of tracking a thing over time, but Git, was hyper optimized in order to be the best thing at the time. He had a very specific goal in mind. But now we're pulling back and we're broadening our understanding of, instead of this is a text file, and we're trying to be as efficient in terms of a certain design decisions of what we think efficiency means, and we're giving dynamics, just thinking of, how do we keep track of something through time. That includes detaching it from our context, right? We've got to be able to cut ourselves off from tracking something across time and then bring it back in. And so we're just talking about dynamics of data mobility, that mobility both through time, right? Because it's never the actual thing. You're always talking about your representation of that thing, your avatar. That's helping our civilization learn that concept. And so we need to think of data as, we can think of it more as living version control. So when we have a robot or a chatbot, right now we have some corporation has some employee, and that employee interfaces with the Git repository of their source control, and they pull the strings on what the chatbot, what its rules are, and there's various ways of doing that. But this already, in using Git as version control, you've put it in a silo of source control, right? But very, very near future, that's going to be just slow and clunky, because now we're thinking of training AI models. Personally, I've been incorporating the distributed computation of AI and IoT and that sort of thing in this from, like I said, that was probably 15 years ago. I still have a whiteboard I call them autonomous services. That was before microservices came up or became trendy. But so each one of these things, when you start thinking of not my silo of data, but this universe or this metaverse of data where the robots are able to manipulate that data, or the AI models, or us. So you have some more shared little pockets of spaces that can transport or intercommunicate more easily than our silos. And that includes the apps. So apps are views into this data, to where apps are like the things where us humans, fleshy humans, click buttons. And in the future, and we're learning more gestures, swiping and zooming and that sort of thing. Those apps themselves can be moved from space to space, but not like right now where you think of, oh, I'm installing this app. It's living on a surface above that. You're living in the application space that's on top of all of what we think of right now as our application layer. So it's a data layer on top of the application layer. So your application can fidget with this data that's immediately thought, not just like, this is not the app's data. This is more your data. But if the way we think about apps right now, we're still thinking in the siloed sense, but we need to be thinking of the apps as just views into this data that's more mobile. Same thing with AI models. So you can think of an AI space. It's going to be easier. Let's see if we have. Okay. So my horrible rendition of what obviously looks like an artificial neural network. So if we do this, we can think of this as being one node in a larger artificial neural network, right? And we can think of this as being the summation of a little network in here. Bloop, 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 whatever. Okay, so, but you can think of these weights and these nodes as being data. This can also be a graph. This could also be, any kind of information that's looked at through a graph. So it is important to be able to take something here and just shove it over to another space. And so that's why it's important to have, just from the beginning, the mindset that each one of your things, each one of your entities is one of these things. It has intrinsic data. It has edges to extrinsic data. And so from the very beginning, that's what we're talking about. With the ibgib protocol, when I go and I synchronize this to the cloud, this is taking, it's doing a tree shaking of only the important data that's related to whatever the thing is. It's getting all of the dependency graph of its entire history and anything it's touched, their entire history. And then it's sending a diff. It's diffing what is new in the in this case, it's synchronization space. It's just diffing it, and then it's synchronizing it by applying transforms, which we looked at just briefly with that DNA. I guess it's a good time to mention what the DNA is. So DNA here, if you know about event sourcing, DNA are like the events that take some starting point. If we go inside of this fork, and then guess what? It's an ibgib. It has intrinsic data and extrinsic data, where this just means this is like a type system. But its intrinsic data is, here's the ib that we're creating. That's our metadata. And then here are some of the functional arguments. And so when we create this ibgib and when we edit it, anytime we do something to it, we create a DNA that we apply to that ibgib to create the new one. So, and that's how we merge spaces that are different spaces. So it's like event sourcing, but you're not just hydrating or rehydrating aggregate. It's just like Git, where you take a branch and you're applying diffs onto that branch, but we're not hyper optimized for text. Right now, we're talking about at the semantic level of we're doing diffs of data, and then we're replaying those diffs of data. So it ends up being, without knowing what a CRDT was, this is naturally one flavor of a CRDT architecture, to where you, in fact, that's how I do the merging, is that if you don't worry about time, and you're just worried about does this DNA, has this been applied to this ibgib, was mutate EF9, has that been applied to the ibgib living in the cloud? Or in a cloud space. So it's just a natural matter of course CRDT implementation that comes from thinking of data mobility. So that's a little dive into the technical side of it. We're right at almost an hour. I'm going to go back, finish this up. Okay, so what can you do? Like the video? Subscribe? Yeah, sure. There are opportunities for a new interface to the YouTube stuff. So again, I'll go back to them. I love IPFS. They're thinking of the enhancements you can get with the peer-to-peer versus a server, a more centralized cloud server, and those kinds of performance benefits. What I'm talking about is an entirely new interaction with videos. Okay. So for instance, what is a pain point of YouTube? I like watching gardening videos, right? Gardening is an amazing thing when you think of time and you look at like these time lapses of these plants growing over time, right? It gives you a completely different view into how time works. So, but you go to like a gardening video and they show you something, and then it's like, well, what about now, right? How did that come out? And some of the creators, they will come back and say, 5 months later, here's sort of what happened, and here's sort of what happened, and these are sort of my lessons learned. What I'm talking about is the ability to shave off like if you already have your garden and you have the data, you're able to export a universe of that data, a replay of that data, to where you can show the progress of different pieces of your garden, your garden universe, your garden dependency graph, and you can see the evolution of individual things and how a decision was made and how that decision, like say to use a certain, like say you have a bug, right? Oh God, I have aphids. Well, what kind of spray did you use, or did you just clip it? Did you add other like did you add marigolds to help attract other more beneficial insects? Did you use diatomaceous earth? So instead of this very disconnected experience with videos, what I'm talking about is a more interactive experience, but still with videos. And then, but we don't want to have just a disconnected digital living experience. The goal is always to be able to get back out and associate with humans. I hear. I mean, I don't. my associations. Well, not too many nowadays. But the point is that you have a little bit more of an interaction with whoever the creator is, and you're able to, just like we collaborate with GitHub and Git for source code, now we're talking about collaboration with context of some universe, of some contextual universe. So I'm saying that this garden bed is like a universe. An individual plant is like a universe of information. You can always, it's changing over time. It has a dependency graph. It has a history. How did it work this season? How did it work last season? How do I share this data in a safe way? And once you solve sharing safe data in a safe way per your use case, then that can be reused for other domains. So in this case, if we're talking about, we're driving it with sharing our garden, but say we want to share our recipes. So we have a recipe is not just something, it's a living thing. If you go to a recipe site and you see in the comments and you say, oh, this person, they added, they changed this part. Like I know when we do a bread recipe, you got to remember, oh, well, it's actually 1.5 teaspoons of salt instead of just 1 teaspoon of salt. It's like, well, that's a living recipe. And we're talking about open source, open data, open collaboration for that domain. In that case, recipes, in the other case, gardens. So with this video, I would love for you to like the video and subscribe just to give me a little bit of feedback. But the long term is not to have that as our contract for interaction, as our only contract for interaction. Same thing goes with comments. Leave a comment. If you're watching this, leave a comment on any aspect of logic in any domain, because this is talking about, again, how we marry that abstract, idealized, discrete sock drawer logic with the real world and an evolutionary biological approach to how we organize our code and the relationship between code and data and metadata. The other thing you can do is you can think about the content. Just look around and see. People are still trying, they're clamoring for this metaverse thing. They're clamoring for this, for a Web3, for a decentralized approach. But people are still thinking of silos, that you just have that mentality. And this is about breaking out of that logic, that siloed mentality. So look around and recognize the opportunity that exists. Also, what this can show you is to appreciate your own value. So just like each, I just said each plant is a universe. Each person is a universe, an infinite universe. We can talk about later about how a corporation forms and the leaders in the corporations, and what happens in a successful corporation. Well, they have to try to raise up their employees to be as self-sufficient as possible, but without leaving the corporation. But that is not. We will have a clearer idea of how to integrate what people think of now as like DAOs, which are very democratic and separated. Separated, meaning you have like these rigid rules for how do you proceed with things, sort of like bylaws in a corporation. But we want to marry again that rigid, discrete approach with sovereignty. So this is your space. If you're part of a corporation, it's not like the corporation is the big thing that you're underneath. Okay, the corporation, its ultimate job is to lift you up, and that's going to be the only way we scale with our distributed computation. You can think of collaboration as distributed computation, and that's how we approach a more eco-friendly, less screen-based digital interactions. And it's that marriage of the digital and the analog, which is what we're going for. So you have to appreciate your own huge value, each and every one of you, but also do so with humility. And that is the thing I'll end on, is talking about humility. So I may sound like I know what I'm talking about. The IB in ibgib is I believe. And that is from the very beginning. When you record data, most people right now think of that data as a fact or as a factoid, right? And what Bitcoin, at the very least, what it should be teaching people is that there is some consensus that has to happen in order for a fact to be established. And right now, we've seen how the world is being riven apart because these people have facts and these people have facts. There's alternative facts and spin on facts. I believe is how we approach sovereign data, to where we are not exchanging facts. We are exchanging beliefs. We are exchanging digitized beliefs. So just because something is in some computer somewhere doesn't mean that that thing is the truth. We don't want to forsake our sovereignty. We don't want to, what is it? We're not ready to hand over the keys to Skynet and take humans out of the loop. This is about how humans and non-humans can coexist and operate both efficiently, creatively, in such a way that, as I like to call it, we overcome entropy. So, but with humility, not doubt, but humility. And that's it. Thanks for watching the video. Oh, I was going to do one more thing, right? Isn't there one more item on here? We got to go back. So slow. My plans for the immediate future. That's right. So I've been working on this solo for quite a while. One of the goals is to get away from a bus factor of 1. We don't want a benevolent dictator architecture right from the beginning. We're going for sovereignty, but also decentralization right from the off. So if you get into contact with me, immediately we're talking about working with each other instead of you working for the corporation of ibgib, or with the ultimate goal. That said, we still, to interact with the world, we'll need lawyers, business people, creative people, visual people. There are many things to do, and that's the beauty of a living distributed computation system, truly a metaverse. For me personally, I want to get that wordy robot working just a little bit better so where I can use it. I want to really kick in some Spanish, although here I gave Italian as the example. But also I need to refactor this, although it would be better to be able to collaborate with that. But to refactor this to where there are a couple things. One, I already had a previous implementation of a version control that was its own thing. So a dog-fooded version control where the ibgib source code was version controlled by the ibgib source code. This allows you to, like, say, when you have a file, instead of needing separate architecture for making a comment on a file, you can have, Bob can go into version control and then say comment, hey, or, oh. So we already have the ability to add elements recursively, and we don't need some other architecture for that sort of thing. So version control, and I need to abstract. So right now, it's very unwieldy for the adapter that I just put in place. I put it in place. It was a DynamoDB adapter. Maybe another video if someone really wants that. I'll show you how to do it. Basically, if you just hit the rocket or something else, it'll walk you through creating a secret, a parameter set for our encryption, and also the adapter's secrets. But that's enough for a whole other video. But me, I have a tendency to over-architect things, and I have over these years. But this time, I just shoved them into the one great. If we add a link here, so here is the great source code, source control. But I need to lock down the spaces to where we can distribute the data more easily. Also, once the spaces are able to synchronize and merge more easily, then you can have multiple apps work a little bit more nicely, or interact a little bit more nicely. But the other big thing is keystones. So this is talking about when dealing with simplicity, we try to reduce the attack surface area for bad actors, as they're called. And right now, the way it works is that when you go to authenticate, somebody has in their team's infrastructure, they have out of band, they have other systems that have logs of things, and but you work with say a PKI system, and that PKI is basically a consensus architecture that exchanges cryptographic data. So again, just like with Git in version control, uh, PKI naturally integrates with this approach, where you can also use a PKI challenge, another external server, but you can have included with the metadata that you're passing along with the data, you can also pass along the challenge data that, like, say for like claims. A lot of times you have claims. So when I go to sign in somewhere, I provide evidence by a password, or nowadays you have um, OpenID. You have other third-party pass. What are the very, very new ones? The passcodes, trying to move away from passwords. But the point is that I have a very natural but unique concept called a keystone. If you want to read about it, you can go over here and you can look at this old. You can read through that. But the point is that while being post-quantum safe, not necessarily secure, but per use case, per whatever your architecture is, you can create an identity mechanism that reuses the same code to pass around authentication and authorization data. So I call those keystones. That's a big undertaking. Right now, these two keystones and the abstract spaces, those are mainly right now, with the bus factor being one. Those are the two things that I personally, in version control, would be best utilized for. But something I am not great at are front end frameworks. This is an ugly prototype. I'm not visual like that. But so these are the key areas that I personally am going to be doing here, walking away from this particular Ionic based implementation. Not walking away from, but improving and refactoring. So that's it. Now we're done, right? We go back here, home. There we go. There's home. I'm just curious. What does the raw, what does it say this is at? We're only on 10 because each one of those changes, each one of those is a timeline within timelines. And so they are decoupled. So even though we did all that typing, on the home, we only changed that 10 times. So that's it, Jib. Logic, living logic. All right. I'm terrible with endings, so we'll leave it at that. Thanks for joining us. Let's archive that one. There we go. Hey, we're done. Thanks for joining me.